This is the video for RC circuits. The R stands for resistor, C stands for capacitor, and it's labeled on the circuit. And there's a switch on the circuit. If the switch is open, the voltage of the capacitor will equal 0. And then if the switch is closed, when the switch is closed, so when t equals 0, the voltage is 0 for the capacitor. And then after an infinite amount of time, the capacitor will equal the number of voltage as the circuit, so it would be 12 volts. When the voltage of the capacitor is 12 volts of the full voltage, then the voltage at the resistor will be 0 volts because of the current will not be flowing through the current circuit. And then the equation that describes the capacitor charging is V equals EMF, which is E, which is also equal to 12 volts, and put that, and then times in brackets 1 minus E to the power of negative T divided by RC. This is the graph for the capacitor charging. The 12 volts is the EMF of the battery, so it's the initial voltage of the battery, or like of the circuit. So here is a basic RC circuit with 12 volts. The resistor is 1000. How long will it take the capacitor to reach 90% of its max charge? Solve for T. That's what it's asking. So take that equation we just saw on the other page. Find 90% of 20, so you do 20 times 0.9, and you'll get 18 volts. V for this equation is the voltage of the battery at 90%, which will be 18. EMF would equal the voltage of the complete battery, which is 20. To find RC, you do 1000 times 500 times 10 to the negative 6, and that'll equal 0.5. So then you take our equation and plug in. So you plug in 18 equals 20 times 1 minus E to the negative T over 0.5 power. Divide 20 to both sides. And so you get 18 over 20 equals 1 minus E to the negative T over 0.5. Subtract 1 from both sides, and you'll get 18 over 20 equals 0.9, and so 0.9 minus 1 is negative 0.1, but because the negative E right here, it would cancel out the negatives. So take the natural log of 0.1, and the E will go away, so you just have negative T over 0.5. Multiply both sides by the 0.5, and you'll get 1/2 times the natural log of 0.1 equals negative T. Once you plug this equation into a calculator, you'll get a negative number, 1.15129 times negative T, and so the negatives cancel. So for how long will it take the capacitor to reach 90% of the max charge? Well, with our calculations, you will get T equals 1.5, so it will take 1.5 seconds to get to 90%. And then here's a simplified, an easier way to get T. With this equation, you just plug in the values that you have, or that is given, to find T. So now we're over here for discharging a capacitor. Here's a simple battery. Discharging a capacitor, this is the graph for discharging a capacitor. You initially start at 12 volts, and it decreases exponentially to all the way to 0. Yep. Equation that describes the graph is V equals V naught times e to the negative t divided by RC. V naught is the original voltage of the capacitor, which is 12 volts. The time constant equals negative t over RC. And so after one time constant, you'll get that the percent charge discharge, or the percent charge, is 36.8. And then so with the voltage of that would be 4.415 volts. And then as the time constants get bigger, so 1, 2, 3, and 4, the voltage for the discharge will go down. So after 2 time constants, it would be 13.5%, and the voltage will be 1.62 volts. 3 time constants, 5%, and 0.6 volts, and 4 time constants, 1.8%, 0.22 volts. And that's when you plug in for this equation. The 12 is the V naught, and then the time constant is when negative t over RC equals -1, -2, -3, -4. Thank you for watching this video on RC circuits.